Irrational numbers. The irrational numbers can be defined as follows. A number S is called irrational if cannot be cannot be written in the form p by q, where p and q are integers and q does not equals to 0. This definition resembles with the rational numbers. A number S is called rational if it can be written in the form p by q, where p and q are integers and q does not equals to 0. Here the thing is, the things which is special with the irrational is cannot, whereas in the rational numbers it will be can be written. That's all is the difference. Which all the numbers which cannot be expressed in the form of p by q are called as irrational numbers. Don't get confused, students. It's very simple. Which can be expressed in the form of p by q are called as rational numbers. Which cannot be expressed are called as irrational numbers. All the numbers excluding irrational numbers can be expressed in the form of p by q, which cannot be expressed are called as irrational numbers. Example for irrational numbers are root 2, root 3, root 15 by 0.10110111011110, etc. You can understand these are the irrational numbers. These numbers cannot be expressed in the form of p by q. Real numbers. The collection of all rational and irrational numbers together make up real numbers, which are denoted by r. Therefore, all real number is either rational or irrational. Every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. This is why we call the number line as a real number line. Locate root 2 on the number line. First, let me draw a straight line. And then we will be cutting this line into several equal pieces. How to do this means, from this point I will be cutting here 1, 2, 3, 4, 5, 6, 7. This point has not appeared here. That's why from this point we will be cutting it as it is. I am not adjusting this one. I will keep as it is here. Yes, right? And then afterwards I will name these points as 0, 1, 2, 3, 4. Here -1, -2, -3. And then afterwards I will take my protractor and I will I will go to the point 1. From here to here 1 is there distance. From 1 I will mark a point at 90 degree. Point at 90 degree, you can see here at 90 degree. And then afterwards I will join these 2 points. These 2 points are to be joined. Yes, right? Oh, yes. I have joined these 2 points, and then afterwards from here to here the distance was 1 unit. I will take this, I have not adjusted as you saw, I have kept here. I will mark here 1. So the distance is right now, no use of this one right now. Here from here to here it was 1. From here to here it was 1 unit. 1 unit, 1 unit. And then afterwards I will join 0 and this point. Let this point be, let us take A, let this point be B, and let this point be C. AC, I will join AC. AC. Now I will take my compass and adjust AC. AC is distance. Yes, right. Yes, it is adjusted. And now I will cut a arc with that. Yes. This point is root 2. This point is root 2. How? Let us justify this. How it is equal to root 2. For this, we have to go to the Pythagoras theorem. Pythagoras theorem. What it says? AB square plus BC square is equal to AC square. What is AB square is 1 square plus BC square is 1 square is equal to AC square. 1 square is 1 plus 1 is equal to AC square. 2 is equal to AC square. So AC is equal to root 2. So this one is root 2. That is, here you can observe that this is 90 degree. This is 90 degree. The opposite of this side of this angle is called as the hypotenuse. So as per the Pythagoras theorem, the square on the hypotenuse is equal to the sum of the squares on the other two sides. As per this statement, AC is root 2. So A to this point is called, let me mark it as P. AP. The AP is, let me use this same number line to locate root 3. Locate root 3 on the number line. So we will use this only as it is the continuation, as this is the continuation process is there. So we will be using this one to locate root 3 on the number line. How to locate means, this is one. If they ask for the examination, locate root 3 on the number line means it is sufficient. If they ask root 3 on the, to locate root 3 on the number line means we will continue with this process. I will place my protractor at the point C and I will adjust it to 90 degree. Yes, right. We should adjust this one carefully and mark a point at exactly at 90 degree. Yes, we got the point here. And then afterwards we should join these two points. This point and this line has to be joined. Yes, right. I join this here. What is the angle means? Here it is 90 degree. And then as in the previous problem, it is root 2 and we have to adjust this one to 1 unit. Yes, right. Yeah, I have adjusted here 1 unit. You see here also same. So from C I will be cutting a arc here. Now this will be 1. This one will be 1 unit. And let me name this point as D. This point as D. And now what I will do is I will cut here a line. I will draw a line here. I'll draw on the line. And this line will be root 3. How it is root 3? Let us move on to the, once again, Pythagoras theorem. So Pythagoras theorem, as per the Pythagoras theorem, this is the hypotenuse. OD is the hypotenuse. OD square is equal to OC square plus CD square. So OD square we have to calculate. OD square is equal to OC square. What is OC square is root 2 square plus CD square. What is CD square is 1 square. Here OD square is equal to, I have written already this one root 3 as I know that one, but let me confirm it by calculation. root 2, root and 2 cancels here. Root and 2 cancels, root and square cancels, plus 1. So OD square is equal to 3. So OD is equal to root 3. This confirms that OD is root 3. So what we have to do means we have to locate it. Still that we have not located the root 3 on the number line. We will be locating this on the number line. So how to locate means we will adjust our compass to OD. Yes, finished now? Yes. Let this point be called as Q. This point is Q, and let me name this point as root 3. Yes, exactly it is root 3. Yes, right? Here we have located the root 3 on the number line. This completes this one. Exercise 1.2. State whether the following statements are true or false. Justify your answer. First one, every irrational number is a real number. True. True. We all are familiar that the collection of rational and irrational number together makes the collection of real numbers. So it is true. Second one, every point on the number line is of the form root 3, where m is a natural number. This one is false. As no negative numbers can be the square root of any natural number. That means where m can be a integer, if it was written as every point on the number line is of the form root m, where m is a integer, then it would have been it would have been true. So that negative numbers can be the square root of their integers. So let us move on to the next one. Every real number is an irrational number. No, false. But the reverse is true. Every irrational number is a real number. That is true. But every real number is not. A real number contains rational numbers and irrational numbers. So it is not false. Because real number contains real number as both rational and irrational. Rational numbers are not irrational. Rational numbers are not irrational. So it is not. It is a false. Example, 2 is real but not irrational. Second question, are the square root of all positive integers irrational? No. We can write straightly no. If not, give an example of the square root of a number that is a rational number. For this, we can give several examples, not necessarily one example. Give an example, it is there. We can give several examples. Square root of 4 is 2. 2 is not a irrational number, it is a rational number. So we can write 9 is equal to 3. An example of a square root of a number that is an irrational. Square root of a number is rational. Yes, right. Yeah, square root of 16, that is also 4, is a rational number. So this completes. Here 2, 3 and 4 are rational numbers. Show how root 5 can be represented on the number line. First, let me draw a straight line. And now I will take my compass and mark and cut this into equal parts. 1. As many as possible you can cut. How long it is? That many times you can cut it. For this I am not using any measurement. Simply I am doing this. And at last I will come to this point and yes, now it is necessary for you to mention, let this be 0 plus 1 plus 2 plus 3 plus 4. Yeah, minus 1 minus 2 minus 3. So here I will use it from 0 to 2. Yes, right, at this 2 point. At this 2.2, number 2 on the number line, I will mark a 90 degree. 90 degree. Yes, and I will join these 2 points. Yes, let this point be A, let this point be B, and then we will mark. You see here, this is 1 point is there. I have not changed. From here to here, I will draw a arc. Yes, finished. No. Next, B, let this be C point, and I will join A point with C. A point with C. From here to here, the length was 2 units. From here to here, it was 2, whereas here it was 1. Yes, no? So, what is the length of AC? That has to be calculated by Pythagoras theorem. Here to 90 degree. Pythagoras theorem. So, AC square is equal to AB square plus BC square. So, AC square we have to calculate. AB square was 2 square plus BC square is 1 square. So, AC square is equal to 4 plus 1. AC square is equal to 5. So, AC is equal to root 5. Root 5. So, this one is root 5. So, this is, we have yet not yet represented root 5 on the number line. So, we have to represent root 5 on the number line. We have found the length of root 5, but now we will be representing it on the number line. Adjust it to the AC and I will cut a arc. That's right. Yes, we got the point. This point, let it be called as Q. This Q point is the root 5 on the number line. So we have represented root 5 on the number line. Here B is there. Okay, don't get confused. This point is Q, whereas this point is B. This is Q, this point Q. That is the root 5 point. Yes, Q point represents root 5 on the number line. Here in the, to locate root 3 on the number line, first we have to locate root 2 on the number line and then only we will get the root 2 length. But no need of writing this arc. No need of writing this one. Simply you find the length of root 2, and then only there is no other way of doing this one. Firstly, we should take 1 and 1 and find the root 2. This one hypotenuse we will get. With the help of this hypotenuse only we can calculate root 3. There is no other way. Okay. But in the case, so we will get root 3 by first we have to locate no, but no need of writing this r, but we have to find the length of root 2. That has to be not to be forgotten. But in the case of root 5, to locate root 5, it's of no need. We can directly find the root 5. We are taken 2, length 2, whereas here we have taken 1. It is a simple construction by which we can locate the root 5 on the number line. But in this one, it is very necessary for us to find root 2. Both are different, but we have done in the same picture. If asked in any test or exam, first to locate only root 2, you should stop at this point only. No need of writing this one. If it has been asked to find root 3, definitely you should find root 2 length, and then only we can calculate root 3 length.